Hello, welcome to day 2 of the unit circle. Now, there was a lot of information in yesterday's lesson. Um, so hopefully you went slow with it. There was a lot to absorb, and unfortunately I have to give you more information for the unit circle today. So let's look at the unit circle day 2. All right, so before I do anything even with the unit circle, I want to go back to SOHCAHTOA for a moment. I want to go back to sine, cosine, and tangent. Now, sine, cosine, and tangent aren't the only three trig functions. There are reciprocal functions to these. And the reciprocal functions kind of almost go like the way sine and cosine went. The reciprocal to sine is called cosecant. And it's abbreviated cosecant. And what the cosecant is the hypotenuse over the opposite. It's literally the reciprocal. The reciprocal of cosine would be the secant, and that would be SEC. And this would be the hypotenuse over the adjacent. And the only one that sounds very close to its own name would be the reciprocal of tangent, which would be cotangent. And that would be adjacent over the opposite, and COT is its abbreviation. Now, I'm bringing this up because these just kind of show up. You know one, you know them all. You know SOHCAHTOA, you know all the reciprocals. But it does take time to let it sink in. The other thing I want to really go into today is a little bit more in depth with the unit circle. Now, when we talked about the unit circle, and then when you watched the video from Kirk Weiler on the unit circle, we said, has a radius of 1. Now, the one thing I didn't go into, because again, I just didn't want to overwhelm you with so much information that you could not even think about absorbing it. Quadrant 1, quadrant 2, quadrant 3, and here's good old quadrant 4. Now, just like we said, this positive x-axis is our 0 degrees and our 360 degrees, and if you're on the actual quadrant, you're a quadrantal angle. Now, if you go up, here's your 90 degrees, which is our positive y, and here at our negative x is our 180 degrees, and at our negative y is our 270 degrees, and then back. Now, the unit circle, again, the word unit meaning 1, and here we said the other day radius is 1, but this is also a radius. And this is the point 1, 0. And here, this would be the point 0, 1. And this would be the point negative 1, 0. And this would be the point 0, negative 1. Now, why are these points so important? Well, they're so important because they go with the quadrantal angles. We said yesterday and in the videos that the x-coordinate is equal to the cosine of the angle, and the y-coordinate is the sine of the angle. So if you go around this unit circle and you talk about the quadrantal angles, you have the cosine of 0 degrees is 1, and the sine of 0 degrees is 0 from the coordinates. Now, I want to make, hopefully you wrote this down, I want to make a little table for this. Now, from this table, let's make a sine, cosine, tangent. A sine of theta, a cosine of theta, and a tangent of theta. And we're going to go across, and we're going to have as our headings 0 degrees, 90 degrees, the quadrantal angles, the 180 degrees, the 270, and then back to 360. And here would be our values. Now again, one more time, even though this is like a little hard or a little repetitious, the sine is always the y coordinate. So sine, we think about, we're going to write y. Now the sine of 0 is 0. Going around, the sine of 90 degrees is 1. Keep going. The sine of 180 degrees is 0. The sine of 270 is -1. And circle all the way back to 0. So these would be all the values for sine on the quadrantal angles. Now let's talk about cosine. Cosine are my x-coordinates. Cosine of 0 is 1. Cosine of 90 is 0. Cosine of 180 is -1. Cosine of 270 is 0. And then back to 360, we're at 1. Tangent's the only one that's a little much to figure out, because we said tangent is not only the opposite to the adjacent. Tangent, if you recall, comes from sine divided by cosine. So therefore, if I want the tangent at 0 degrees, I have 0 divided by 1, which is 1. If I want the tangent at 90 degrees, that's going to be 1 divided by 0. This is undefined. Can't divide by 0. There's no such thing of tangent at 90 degrees. Don't believe me? Type it in your calculator. You'll get an error message. The tangent of 180. Well, 0 divided by -1 is still 0. And the tangent at 270 is now -1 divided by 0, which again, undefined. And then the cosine of 360 would be 0 divided by 1. And so you would have 0 again. So tangent goes between 1 undefined, 0. Wait, duh, that was stupid. I said 0 and I wrote a 1. It's going to 0, undefined, 0, undefined, and 0. Whew, had to fix that. Sine and cosine, they'll go from 0, 1, 0, -1, 0, 1, 0, -1, 0, 1. Now this is actually going to become an extremely important chart. You are going to want to never forget this chart. You're going to want to write this someplace where you'll find it, because this is going to even become the basis of all the sine and cosine graphs we're going to make. So really important. This comes from the unit circle, and we don't want to ever forget about that. Now the other thing that we would get on the unit circle is if we had angles that were from the special triangles, the 30, 60, 90, or the 45, 90. They're all in the unit circle, as you saw and you drew yesterday, because I saw it from a lot of people, and it's very, pretty important stuff. Let's just put those up for 1 second. So if I had a special triangle, and let's say I drew it in quadrant 1, where both x and y are positive. So if I'm talking about an angle in quadrant 1 from the unit circle, so this is my point, 1, 0, but I were to be talking about an angle here, now let's say we're talking about 30. Well, like I said to you the other day, it really doesn't matter what 30, 60, 90 triangle you have. When you make the ratio, they're going to always reduce down to the ratios from our triangle. So our triangle, just for argument's sake now, would be opposite the 30 is always going to be 1 and 2 and then the 3 with the radical. So if I put a 30-degree special triangle in here, again, regardless of any other number you're going to get, it's going to always reduce down the ratio. So we're going to always go with the reduced version. And if I make a table with the 30 degrees, with sine, cosine, and tangent, and I then have my 30-degree special angle, the sine of 30 degrees is always going to be in a 1:2 ratio with the hypotenuse. The cosine of 30 degrees is always going to be the adjacent to the hypotenuse. Now the tangent is the opposite over the adjacent, 1 over rad 3, but if you recall, we made this into rad 3 over 3. We rationalized it. Now if I were to have my 60-degree, and I now want to make this into 60 degrees, I'm just going to erase this over here. If my angle, my theta now is 60 degrees, the hypotenuse is still a 2, but when you have 60 degrees, the adjacent side is 1 and opposite would be the rad 3. So now, because this would be 30 degrees up here, so that's still a 1:2 ratio with the hypotenuse. But the sine of 60 would now be the rad 3 over 2. The cosine of 60 would be 1/2, 1:2. And then the tangent of 60 would be opposite to the adjacent rad 3. So it changed somewhat because the angle, the perspective changed. Now let's talk about if I had my 45-degree angle. If this now were a triangle, and I had a 45-degree angle in here, again, regardless of what other, whoops, that doesn't show up good, regardless of what other numbers we're talking about, we're going to always reduce to these ratios. So if I put my 45, the legs we said were 1, and the hypotenuse was rad 2. So now 45 degrees. My sine of 45 degrees was 1 over rad 2, and it rationalizes to rad 2 over 2. Cosine, same thing, 1 over rad 2, rad 2 over 2. Tangent is 1. Now, these two charts are going to become values that you're going to need to know. You can draw them out or you can memorize the chart. I don't really care which way you go because you have to work with what works better in your brain. And from that, knowing these two things, we now have to combine this with converting between degrees and radians, radians and degrees. And we have to combine it with our unit circle where quadrant 1, all functions are positive. Quadrant 2, only sign will be positive. And that even goes along with the cosecant, the reciprocal. In quadrant 3, only tangent is positive, and cotangent now, the reciprocal. And in quadrant 4, it would be cosine is positive, and cosine's reciprocal, which is secant. And we're going to see that on this new handout that you're going to be looking at. So I'm just going to now erase some of these things because it's a little too much on the page. So I hope you either took a screenshot of this or you copied it. If you didn't, rewind back and do that because you definitely are going to need it. Now, the second day of work is a packet. It's going to say Unicircle Day 2. And it has a couple of, the first page is a warm-up page, which I think I'm going to actually work through with you together, just because I think it's a little bit helpful. Number 1 says, find the exact value of the secant of negative 3 pi over 4. Okay, well, first of all, what are we talking about with 3 pi over 4? So I'm going to take my 3 pi over 4, and I'm going to convert this into degrees by multiplying by 180 over pi. If you remember this from lesson 2, diagonally the pi's are going to reduce. 4 goes into 180 45 times, and 3 times 45 is going to give me a 135 degree angle. So this is now saying I want the secant of negative 135 degrees. Well, if you recall from lesson 1, negative means I am going to draw, I am rotating clockwise. So we're going to be pulling everything together, and I know this is going to be a little bit of a challenge, so just take your time. So here's my picture. Here's my 0, my 90, my 180, and my 270. But now I'm going clockwise. I'm going clockwise negative 135 degrees. So I went past negative 90, and I didn't quite hit negative 180. Here's my negative 135 degree rotation. It landed me in quadrant 3. Quadrant 3 is tangent's quadrant. That means secant is going to be a negative value. But what's my reference angle? Well, if I stopped at 135, my reference angle would be 45 degrees more to hit 180. So let's now say the secant of negative 135 is actually the same as the secant of 45 degrees in quadrant 3. But here's the thing. Secant, who's the reciprocal of cosine, so if I write over here my SOHCAHTOA, and my reciprocals, this would be cosecant, which would be hypotenuse over opposite. My secant which would be adjacent over hypotenuse, and then my cotangent would be adjacent over opposite. If secant would be negative in quadrant 3, if cosine rather would be negative in quadrant 3, secant's negative in quadrant 3. So I put the negative now because the negative here is telling me location. This negative here told me to rotate clockwise. Now I landed in quadrant 3. Now this negative is telling me I am in a negative quadrant for cosine. So if I want the secant of 45 degrees, and the value is going to be negative, let's write the negative in. First thing I'm going to think about, so in my little thought bubble, I'm going to think, what is the cosine of 45 degrees? Well, that's where that little chart that we just had comes in. The cosine of 45 degrees came originally from 1 over rad 2, and then we rationalized it. But I'm going to go back to what it was before I rationalized, because now he's the reciprocal. He's this guy flipped over. So this would then be negative rad 2 over 1, or just regular old negative rad 2. That was a lot of work. And you have to go very, very slow with this. You have to draw a picture, and you have to go through all your lessons 1, 2, and 3 so far. It's quite a bit. So I'm going to give you the time to let this sink in. Let's take a look at number 2, tangent. And believe it or not, every time I do a problem, I redraw everything out. So when you see, when I post my answers, actually I probably should have left that guy on here, but I'll put that back. When I post my answers, you're going to see I write every single step out that I'm asking you to write out. It's on my paper as well. Let me just go back to having my sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, and then the reciprocal. The cosecant would be hypotenuse over the opposite. The secant would be hypotenuse over adjacent, and the cotangent adjacent over opposite. So that I'm not going to erase now. So number 2 on this first page says, what about the tangent of negative 7 pi over 6? Well, again, here we go. We got to take 7 pi over 6 and we have to convert it. So the negative we'll worry about with the rotation after we convert it. So if I take 7 pi over 6 and I multiply it by 180 over pi, I convert to degrees, pi's cancel, 6 goes into 180 30 times, 7 times 30 gives me 210 degrees. So what this means is that I now have the tangent of negative 210 degrees. So here, this means, again, clockwise. And here, I am going to go 0, 90. I always label. I never not label. Now I have to go negative 90, negative 180. 180 and 90 is 270, so I'm right in here. I didn't quite hit 270. I was at 210. So if this is my negative 210, what's my reference angle? Well, how far beyond 180 is 210? And that would be a 30-degree reference angle in quadrant 2. Now, in quadrant 2, if we go back to all students take calculus, this is sine's quadrant. Sine and cosecant would be positive. That means tangent is going to be negative. This is now going to be equal to the negative tangent of 30 degrees. So 30 degrees, the side opposite the 30 to the hypotenuse is always in a 1:2 ratio, and then here's the 3 with the radical. Label is the key. Tangent, opposite over adjacent. It's in quadrant 2, so it's negative opposite over adjacent, which then simplifies to negative 3 over rad 3. And again, it was in the chart that I hope you copied that have right here. So now, let's do cotangent of 315, and then, no, actually that one you could do without me. Let's do the sine of 690. Let's take one that's a little bit more, you have to go around, so you're going to need a coterminal angle. So let's start with that one now. So we're going to skip 3 because I think you could do 3 without me. And we're going to go to 4 because I think 4 might look a little challenging, and then see what you could do. Number 4 says the sine of 690 degrees. Okay, way beyond 360. So if I subtract 360 from this, I get sine of 330. These two guys are coterminal angles. They land in the same place. So a 330 degree angle, if I draw this out, 0, 90, 180, 270, back to 360, I am almost at 360. Here is my 330. I'm in quadrant 4. And quadrant 4 is cosine's quadrant. Here I'm sine. So the sine of 330 degrees is equal to the reference angle, which would be 30 degrees. I need 30 degrees more to hit 360, is equal to the sine of 30, but I'm in quadrant 4, that makes me negative. So this again is my location. The sine of 30 degrees is a 1:2 ratio with the hypotenuse. So the sine of 30 is 1/2. In quadrant 4, it is negative 1/2. Now these are exact answers. They're exact answers because I am not giving decimals. I am not getting rid of the radicals. I'm giving you exactly what I get from knowing my sine, cosine, tangent of my special triangles. And now here's one with the quadrantal. Number 5 is a quadrantal. So let's take a look at 5. So number 5 has the cosine of 270 degrees. Well, 270, 0, 90, 180, 270, woohoo, it's a quadrantal angle. So I think about my unit circle. This is the point. 0, negative 1. Cosine is my x-coordinate. Cosine theta is the x-coordinate on the unit circle. So therefore, this is 0. So the quadrantals, boy, those are nice. So I'm going to ask you on this page to do really just 3 and 6. And take a look at my work and see how you were able to tie things together. When you go through the second Unit circle, a lot of these are going to be straight from the Regents. These are all questions that have shown up on the unit circle in the Regents. Draw them out, go through all the notes I gave you. I'm going to post my answers, by the end of the night. I'm going to give you time to do it yourself first, and then I'm going to want you to go and I'm going to want you to check your work. I'm going to want you to let me know if there's a problem. Please email me, please text me, you can't text me, email me, message me on the classroom. Just do whatever you could do to let me know when you don't understand. Good luck.